Hey guys, I'm going to work a problem that is very similar to the lottery ticket problem from this week's Math Lab homework. But instead of talking about a lottery ticket, we are talking about a passcode that you're trying to come up with. The passcode's got 6 characters to it. So I'm just going to put like 6 blanks here. 1, 2, 3, 4, 5, and 6. So there are 6 characters in the passcode, and we know that it's made up of the letters A through F and that they can be repeated. So A, B, C, D, E, F. Okay, that's 6 different letters that you have to choose from. So the step I'm getting ready to do right now, I am not explaining why I'm doing what I'm doing because I'm hoping that you have already looked at the explanation that is also attached to this post where I directed you to mathisfun.com, a really great website where it explains what I'm doing here, which is the fundamental counting principle. So if you haven't checked that out, you might want to do that so you understand why I'm doing what I'm doing. Okay, so we've got the 6 different letters for the passcode. There are 6 different possible letters that could go into the blank because they can be repeated. So that means for the first character, I've got 6 options. For the second, I've got 6. The third, I've got 6, etc., etc. Because every single time a character in the passcode could be one of those 6 letters. So to find out how many possible combinations of passcodes there are, you're simply going to take all of these 6s and you're going to multiply them. So I'm going to multiply 6 times itself 6 times. And if I do that, I get 46,656. So there are 46,656 possible combinations. Again, the way I got that is that I knew that there were 6 characters in the passcode, and for each of those 6 characters, there were 6 different letters that I could choose from. So I had to multiply 6 times. So I got a total of 46,656. Just for the sake of clarity, let's say that I'm going to change the rules a little bit here. And it's still a 6-character passcode. So I've still got my 6 options here. But instead of A through F, let's say that it only could include A through C. Okay, so A, B, C. Obviously, that's 3 different possible characters, right? So that means that I need to fill in each of these blanks with a 3 because each of the characters in that passcode could be one of 3 different possibilities. So I would multiply all of those 3s, or for the shortcut, for those of us that don't know, I could also just put into my scientific calculator 3 and raise it to the 6th power because that means the same thing as multiplying 3 6 times, and that means I have 729 possible combinations. Anyway, back to the original problem. So where I had 6 combinations originally, I multiplied that 6. I did 6 to the 6th power, multiplied 6 times. So again, going back to that problem, we had 46,656 possible combinations. So now for part B of the question, what is the probability that you can guess the correct passcode? Well, out of those 46,656 possible combinations, only one of them is the magical one that is right. So the probability that I would select the correct one would be 1 out of 46,656. And you don't need to divide that into a decimal. That would be a very tiny decimal. You can just leave it as is, as a fraction. Hopefully that helps, and let me know if you've got any other questions.